Alright guys, I just have a couple things I want to tell you about free fall tips. When you're answering questions about free fall, there's a couple just easy things that you can remember and know that'll help you because a lot of these questions are somewhat tricky if you don't remember these tips, but the tips help you so much. So, excuse me, let's start with this. First of all, free fall. If an object's in free fall, it means that it is only experiencing gravity. So the only force on it is gravity. So that means that there's absolutely no air resistance or any other force. So for example, if we drop a feather on Earth, that feather is going to bump into air molecules and it's going to float down to the ground. That is not free fall. We have to either pretend like there's no air, or we can physically suck out the air with a vacuum or some other pump that just gets rid of the air. And then we're talking about free fall. Um, Free fall, excuse me, sorry about that. Free fall is a model that simplifies real motion. So feathers are complicated and pieces of paper and light things are complicated, but if we take a bowling ball and we drop it, it will experience air resistance, but we can basically ignore it because the bowling ball is so massive and so dense that it doesn't, the air resistance is pretty negligible, assuming lots of things like we drop it from a short distance, yada yada, but you don't really care about all that. Really, what I'm saying is we can pretend like there's no air resistance in a lot of situations, which is what we do in physics, because especially in AP Physics 1 and Honors Physics, it's hard to include air resistance because it's kind of calculus based. So obviously we're not working on that right now. So anyway, um, that's how you know something's in free fall. So if it's just falling, or even if you throw something upwards, um, and after it leaves your hand, now there's no more force on it except for gravity, then it becomes in free fall. So I'm just gonna hopefully that doesn't mess everything up. I'm just gonna add that on here. So it can be in free fall if it's just dropped, or if you throw it up, or even um, and basically throw it at all, but as long as it leaves your hand and there's no other forces on it after it leaves your hand. All right, then it becomes in free fall. Here's the thing: the acceleration of an object in free fall is always g, which is negative 9.8 or negative g, I guess. G is 9.8 meters per second squared. It's the acceleration due to gravity. So objects in free fall will always accelerate at that rate. Here's the big tip that always helps. Sometimes when you're reading word problems about free falling objects, they don't tell you what the acceleration is. They won't say, an object starts from rest and it's moving at a certain speed and the acceleration is negative 9.8. They're just not going to say that. So instead, they just say this object is dropped, and it's up to you to remember that an object that's in free fall is going to have an acceleration of negative 9.8. So you have to put that in on your own, all right? Now, when you're doing multiple choice problems and you just need to estimate in order to get a quick answer, you can just usually estimate to negative 10. 9.8 is close to 10. So if they have other easy numbers and you can just do the math in your head with 10, sometimes it's just nicer to do that. Obviously, this is only one sig fig and this is two sig figs, so you lose some of that accuracy, but if it doesn't matter, then you can just estimate with 10. Here's the big misconception. A lot of people think, and this is going back hundreds of thousands of years, I suppose, that heavier objects accelerate faster. If I drop a feather and a hammer, they're going to accelerate differently because the feather is light and the hammer is heavy. That is wrong, absolutely wrong. And the reason why that happens is what I said before. There's air resistance. If you could suck out the air and drop the feather and the hammer without any air, they would both accelerate to the ground at negative 9.8 meters per second squared, and they would hit the ground at the same exact time. That's super important. Um, I'm gonna upload a video that shows you that. And there's a MythBusters. There's also the video. They did this on the moon. They actually brought a feather and a hammer to the moon when they went and they dropped it and they confirmed it because there's no atmosphere on the moon, there's no air on the moon, so they were able to show it that way. All right, next up, when you throw a, oh, actually, I meant to show you this too. Notice that acceleration just means that you're changing your speed. So at the first second, it has a 0 speed. The second, it has 9.8. Or I guess that's the first second. Then the second, it's 19.6 because that's 9.8 plus 9.8. So you can see we're increasing our speed by 9.8 each time. Throwing up a ball in the air. The time is 0, distance is 0, and the speed is, or velocity is positive 20. So I throw it up with positive 20. It goes up. The After 1 second, remember, if we estimate to negative 10 meters per second, the initial speed has lost 10, right? Because it's a change of 10 meters per second in 1 second. So now I've lost 10 meters per second, so now I'm going slower. I've gone a distance of 15, and it's been 1 second. At the very top, here's tip number 2, big tip number 2. The highest that it goes, which is D, the highest height that it goes, its velocity is 0. It stops for a moment after you throw it up, and then it begins to fall again. So that distance is 20. That's the max height, I mean. And whenever you're at your max height, it is always a velocity of 0. That's super important, all right? Then, of course, it falls back down. Its speed or its velocity now is negative 10, and then it goes back to negative 20. And that's kind of the gist there. But I really wanted to show you this. Now, here's the thing that a lot of questions will ask on the test, on the exam. They'll try to trick you, and they'll ask you, you throw a ball up in the air, and they want to know, is the velocity positive? Is the acceleration positive? Yada, yada. After the ball leaves your hand, the acceleration, I mean, becomes negative 9.8. The minute it stops touching your hand, it's negative 9.8. So here at this moment, it's negative 9.8. Here at this moment, here it's negative 9.8. At this moment, even when it's at rest for that brief moment, it's accelerating negative 9.8. Here it's accelerating negative 9.8. Here it's accelerating negative 9.8. The entire time it's in free fall, it's always accelerating at negative 9.8. Okay? So, the other thing they're going to confuse you with is the direction. Is the acceleration positive going up and negative going down? No, it's negative the whole time. Negative 9.8 going up, negative 9.8 going down. And if you're like, wait a second, that makes no sense. If it's going up, it must be positive. If it's going down, it must be negative. Yes, but remember you're using that word it. What is positive and what is negative? The velocity is positive. The velocity is negative on the way down and positive on the way up, negative on the way down, but that's the velocity. The acceleration, which is the change in the velocity, is constantly negative because of gravity pulling it down, even though it's moving up in the beginning. All right, so I hope that helps. That's usually a very common question. Finally, I have some graphs of the motion. So if I start an object up high here and drop it, it starts off falling slowly and then it speeds up as it falls, and the acceleration is constant. If I were to look at the velocity, notice that was a position versus time graph. If I look at the velocity versus time graph, you can see that it is a straight line down with a slope of, guess what? Negative 9.8, because that is the acceleration due to gravity. And here, these graphs are a displacement, velocity, and acceleration graph showing what happens when you throw a ball up. So this graph here is literally the graph version of this. So you throw a ball up, it gets slower, slower, slower. It comes to the max height that it has, and then it starts to fall back down to the ground. Then our velocity is positive. The slope is positive in the beginning. Then the slope turns to 0. At this point, the slope is 0, which means the velocity is 0. And then, of course, the velocity gets more and more negative as it falls back down. And the slope of this is negative 9.8, which looks like that right there. That's the acceleration, negative 9.8. So I hope that helps clear some things up about free fall.